All right, this time nomenclature. And this time we're going to do polyatomic ionic. The polyatomic ionic ones contain a polyatomic ion. And the way you'll know it contains a polyatomic ion is that it has 3 or more capital letters. Again, the binary ones have 2 capital letters. The polyatomics have 3 or more. So when we see that, 3 capital letters, we know that's polyatomic ionic. There's a polyatomic ion in there somewhere. Again, we see that there's 3 capital letters in there. We know there's a polyatomic ion in there somewhere. So binary have 2 capital letters. They have their own set of rules. Polyatomic ionic have 3 or more capital letters. They have their own set of rules. There are some I expect you to memorize, polyatomic ions. There's NO2, has a -1 charge. That's nitrite. There's NO3, has a -1 charge. That's nitrate. There's SO3, -2 charge. That's sulfite. SO4, -2 charge, sulfate. There's PO4, -3 charge, that's phosphate. There's OH, -1 charge, that's hydroxide. And there's NH4, +1 charge, that's ammonium. The only positive one is ammonium. The only ones that don't end in IDE or ITE are hydroxide and ammonium. ATE and IT are the most common endings. ATE means more oxygen, ITE means less oxygen. Again, ATE, more oxygen, ITE, less. These are the ones I expect you to know. You need to know their formulas, their names, and their charges. The nomenclature rules for these are similar to the binary ionics, except we don't have to change any endings. So we're going to split it. Not necessarily in half this time, but into positive and negatives. There'll be a positive ion and a negative ion because it is ionic. We'll write down the name of the first part. We'll write the name of the second part. No endings to change this time. Just write the name. And again, we have to check the Roman numeral thing. And it was the same as it was for the binary ones. You look the metal up on the periodic table, you see if you can find its oxidation number or not. If you can find the oxidation number, if it is a predictable metal, groups 1, 2, and 13, then no Roman numeral. If it's a transition metal, then you're going to have to calculate it and stick the Roman numeral in there. So NaNO3, our first substance. Again, we got to split it into positive, negative. We have to recognize that NO3 is a polyatomic ion, and the split goes right there, with sodium on this side and NO3 on that side. Most of the time, it's going to be a metal for your positive part, and then the polyatomic ion for your negative part, because again, if you look at the list, they're almost all negative. The only exception is ammonium, NH4. So again, we start by writing down the name of the metal. Then we write down the name of our polyatomic ion, again from the list. It's nitrate. Then we have to check to see if we need a Roman numeral. Sodium is in group 1. Group 1 is always a +1. So it's predictable. There's no need for a Roman numeral there. The name is sodium nitrate. Now we go to the other one, the FeOH2. Again, we've got to split it into two parts, positive and negative. And again, most of the time the positive is going to just be the metal that's in there, just like it is here. The negative is going to be one of our polyatomic ions from that list up here, one of these things. We've got to recognize it, and there it is, OH. And write down the name of the first part. Then write down the name of the polyatomic ion. That's hydroxide, again, just from the list, same name. Now we have to decide if we need a Roman numeral. To do that, we look the iron up on the periodic table. Iron is in the middle of the periodic table. It's a transition metal, so it does not have a predictable oxidation number. So we are going to have to calculate a Roman numeral this time. Same rules we had before. Find the total negative charge. Hydroxide is a -1, right there. We have to multiply it by the number of hydroxides. And here's the deal. If there are no parentheses around that polyatomic ion, there's one of them. If you do have parentheses, you go with the number on the outside. So we have parentheses. That means that there's more than one hydroxide. And the number on the outside is 2. So it's -1 times 2. So -2 is the total negative charge. We'll make it positive and divide by the subscript on the metal. So it'll be +2. There is no subscript on the iron. That means there's 1. My Roman numeral here is 2. Now that will cover most of them. That will cover most of the polyatomic ionic, but not all of them. It won't cover the ones that start with ammonium NH4. In that case, you just name it like a binary one. It's ammonium something with an IDE ending. So if ammonium's your polyatomic ion, it's the first half, and you just treat it like a metal. And that's all there is to it.